Okay, so first we discussed till this particular slide yesterday. Do you have any questions? Any kind of questions? And just to be on the same page and revise the yesterday's concept in case if someone missed. In summary, we have discussed yesterday what is big data. Big data is nothing but a problem. Big data is a problem that we solve using Hadoop. Hadoop is an open source framework to solve big data problem by using two key components of it, which is HDFS and MapReduce. Anyone has any questions so far? Are we good? So if someone would ask us what is big data, we can tell them that what is big data. If someone asks us what is Hadoop, we can tell them what is Hadoop, what is HDFS, what is MapReduce, how they are like related with each other, and what we are trying to do with Hadoop, where we have started from as a standard distributed file system to HDFS, that is Hadoop distributed file system. Okay, I hope there are no questions. Let's move on. And this is now question is of data locality. So what is data locality? So on the left hand side, you're able to see that traditional DFS, what a traditional DFS has. And actually you're able to see the similar thing on the right hand side, the HDFS. Now the key difference actually that's there. Can anyone tell us what is the key difference?
On the right hand side in the Hadoop distributed file system, we have one program is there that is basically managing all the storage.
Okay.
Something like that.
Mm-hmm.
Yeah,
cool.
Like we have different system to storage the data, but for master it is like a single system.
Okay, I need one volunteer to just answer some common sense related question and to the best of their knowledge. Anyone can vouch. Just raise your hand and I'll pick up that guy. I think I'll pick up the last one. How about Vinayak? Vinayak, are you there? Hello, Vinayak? Vinayak is there, yes. Would you like to unmute yourself? Or would you prefer like the chat thing? You want to answer in chat and want to unmute? Either way, it's fine. It's just that unmuting will be easier. Actually, my mic has been glitched. Oh, okay. In that case, I'll pick someone else. Let's take, how about Akshat? Akshat? Are you there? Okay, Akshat is also not responding. There might be some issue. Then let me take Rupesh only. Rupesh, I like your help. Okay. Now, first tell me this. If I say that, Rupesh, you have a 1 GB of a file. Okay.
Sorry, your voice was broken.
We have 3 slaves.
Your voice was broken, Shubham.
Yeah. I'm sorry.
Hello.
Hello. Is it better?
No, yeah, yes. Now we can hear.
Perfect.
Can you repeat? Can you repeat your question?
Fine now. Yes, it should be fine now, right?
Yes.
Perfect. Now, let me ask you this question, where I'm saying that you have a left-hand side. Okay. Right now, we will be focusing on this left-hand side where we are doing the data transfer. Okay. What I'm saying is that Rupesh, you have a master system which has a 1 GB of file. Okay.
Mhm.
And you have 3 slaves, S1, S2, and S3. These 3 slaves have a program. So let's say I just want to, how should I put it? I want to, let's take simple example of counting words. I want to count words in that file, 1 GB file. Okay. Simple
Okay.
example. Now, these S1, S2, S3 has that program. All these 3 slaves have the program to count the words, your Python code or your Java code. Okay.
Mhm.
Now your master has that 1 GB file. In order to do the distributed processing, what would you do?
We will basically break that 1 GB file in 3 parts and transfer each part to each of the subsystem, and
Completely agree. Completely
and
agree.
they will basically do their task and
Parallelly, correct.
return that count
To
to
the
the
master.
master.
And then
Yeah,
master will consolidate the count. Correct. So master, but so essentially what Rupesh is saying, that Rupesh will split that file into 333 MB each and send it to S1, S2, S3. Then S1, S2, S3 in parallel will do the counting of the words. Let's say this one has given 250 words, this one has given 200, this one has given again 200. So they will send this number to master. Master will consolidate 200 plus 200 plus 250. That will be around 650. And that will be the answer. And your task will be done within the 1/3 of the time. Because if master would have done it, it would have done it serially.
right,
Correct? This is what Rupesh is saying, correct?
right.
Anyone here who disagrees with this concept? I need 3 yeses. Okay, no, yeah, 3 no's if everyone agrees with it. One Sayali has said no, KK said no, Vinayak said no. Okay, so all are with me and Rupesh so far. Now, I need to ask this question to Rupesh. Rupesh, wouldn't it be actually difficult to send 333 MB over the network? Like your bandwidth won't be consumed. Like this master need to send 333 MB here, 333 MB here, 333 MB here.
That bandwidth will be consumed. Yes,
That will be consumed.
network
Okay.
time will also included.
Network time will also be perfect. And what if there is a network issue?
Then our
Then
task
you
will
have to
be
wait.
very, yes.
Then you have to wait until and unless the data is not transferred, correct? So
Right.
there are X number of cases related to transferring the data. And right now I was talking about 1 GB. What if this file is 1 TB? Then you have to send, then you have to use more network bandwidth. That is 333 GB each you have to send.
Correct.
And what if your network speed is slow?
It will take a lot of time.
Yes. So your time is increasing as soon as your data size is increasing and proportionately, correct?
Right.
Okay, this is our traditional distributed file system, what it does. Now, Google engineer came up with a very innovative and very clever way, and they created Hadoop distributed file system. What they said was, okay, what I'll do is I'll store my data on S1, S2, and S3 itself in the first go. I'm not going to send it to master. So they were smart guys. So they said, I'm going to store 333 GB on S1, 333 GB on S2, and 333 GB on S3. Instead, what I'll do is in Hadoop distributed file system, my data will be directly stored on my HDFS layer, that is in S1, S2, S3. And instead of sending the data from master to S1, S2, S3, I will send the program that need to be run on these 3 machines. Now, Rupesh, can you help me out? What would be the program file size? Let's say you have written a very long program. What could be the size of that program?
1 MB or less than 1 MB?
Less than 1 MB, correct? Because 1 MB is very huge, right? 1 MB textual file. Yesterday only,
Right.
if you remember, when I was typing one single character, it was taking 1 byte.
Correct.
So 1 MB will be 1024 into 1024 into 1024 bytes. Because 1 byte, 1 kilobyte will have 1024 bytes, correct? And then
Right.
1 MB will have 1024 KB. So we are talking about 1024 into 1024 into 1024 characters. So either it will be less than 1 MB, mostly it will be less than MB, or can be 1 MB. Now, if I ask you, Vish, wouldn't it be easier to send 1 MB to this S1, S2, and S3 and get the result?
It will be easier.
It will be easier. And wouldn't it be much faster in terms of network bandwidth also?
it will be very
Now-
faster. Yeah.
Correct. And isn't it irrespective of the data size? Like if it is 333 MB on each of these slaves, or is it 333 GB on each of these slaves? Your 1 MB file will be always same, right? No matter what the size of data you have on S1, S2, S3.
Right.
So correct. So what they did was they were very smart and they came with this innovative approach. They were not transferring the data. Instead, they're transferring the program. And that's how Hadoop became our next, you can say, big leap in distributed computing and became our go-to data processing engine. Everyone so far with me? Anyone has any question? Why Hadoop is famous? Why Hadoop is better than traditional systems? What is data locality? The reason we are saying that this concept is of data locality is because data is not traveling, program is traveling. Thank you, Rupesh. If you have any questions, feel free to ask.
Data locality means like data is not traveling. It means data is on the same systems.
Data
I
is
think-
residing where it was, yes. In
Okay.
this traditional system, if you will see, we are moving the data from master to slave, and there is a lot of data movement. Here, there is no data movement. Data movement is zero. Program movement is there.
But first of the time we have to transfer data for the very first time in the Hadoop also, right?
Think of it as I'm not taking into consideration in this system the time to get data into master. We haven't taken that time into consideration, right?
All right.
So we are assuming that the time taken to get data onboarded to master will be equivalent to time taken to data getting onboarded to this HDFS layer of S1, S2, S3.
Okay.
Assuming that is same, then we are making this comparison. Yes, Akshay, you have your hand raised.
Yes, actually my question was that only like in the Hadoop also, because in the first go we have to like transfer the data from S1 and S2 and S3, right?
That we are, so that anyway we have to
Yeah.
do everywhere, right? So we are not taking that into consideration. That is out of question. Because right now we have not considered that loading data onto master. Here we are not considering loading data onto HDFS layer.
Okay.
Okay. Because let's say even if you do that, right, we will be assuming that is equal. I'm assuming right now that is equal. And then the rest of the comparison will come into place and Hadoop will win. But we all know now why we are choosing Hadoop, what Hadoop has like to offer, why Hadoop is much better than the traditional distributed file system. Because it is removing a lot of variables like network bandwidth availability. 1 MB program, how much net doesn't matter. 1 MB is always going to be there. Like it was there in 2G, 3G times also. Right now we are moving towards 5G. In terms of wireless bandwidth availability. Over LAN, you have now gigabit. So 1 MB is not a problem in today's world. Again, irrespective, so network bandwidth availability is out of question now. Data traveling time, which was here, there that is zero, irrespective of what your data size is, 333 MB or 333 GB. Then what else?
Shubham,
Yeah.
One thing. Only program is moving from S1 to master means that counting of word for a component.
Correct. And not it is not moving from S1 to master, it is moving from master to S1 in Hadoop.
Means whatever program master has, that program is basically transferred to S1 and S1
And S2
count
and
that
S2.
word.
Yes.
Yeah, and then
what S1 will do is it will execute that program on its machine and then it will give the result back to master.
Program is only moving right.
Correct. In this case, what we were assuming, data is coming to S1 and program is already existing there. Although that was just an assumption. There are different types of traditional distributed file system that we had. So that we're not going into those details. They are connected to each other and then there are X number of things that how we are moving again program to all of this system and why we are assuming there. That's a different topic. But yeah, right now, a fair comparison, in order to make a fair comparison, we are saying that program here exists already, here data already exists. Yes, Mihir.
Yeah, sir, hello.
Yes.
Yeah, sir, so can we say that in the Hadoop distributed system, the role of the master is to provide the functions and not the data.
Yes, role of the master is to manage. So just to be on the same page, on the next slides, what I'm going to tell you, there's this master is just you can say a manager.
Okay.
It does not do anything else. It manages. It is a metadata driven master. It will store everything. It will know what is where. It will never have the data itself. It will always have the location of the data only.
Okay.
So if you're going to ask me, Shubham, can you tell me what does S1 has, like file name? So that information is there in master.
Yeah.
S1 has no knowledge of what file I am getting or what file I'm having.
Yeah.
Okay.
Yeah. So it is basically having the paths to the different data storages.
It has, yes, it has knowledge of everything. Which node has what data and where is it residing? Where is the replication? What is the network availability? What is the heartbeat signal of that? So there are different components that we're going to discuss that will come into Hadoop architecture. We'll be discussing those.
Okay, thank you.
But yeah, data locality concept, why we are saying data locality is there in Hadoop data, HDFS is everything, everyone is good now. Correct? Anyone has any questions?
Shubham, what is, difference between data transfer and program transfer? Like, suppose if we have an Excel file, that is data, right? Like
that is data.
So data transfer means that Excel file will be moving into S1.
Yes.
And what about in Hadoop DFS? What
HDFS
will be transferred here?
Yes, but we are assuming that if you remember, right, yesterday we were saying that data will be stored in terms of blocks, and by default block size will be of 64 MB. Correct?
Yeah.
So what will happen is, think of it as data will be divided into that 1024. Give me a sec. To realize, like, to be on a very precise manner. Let's say 1 GB. 1 GB is 1024 divided by 64. Okay, there will be data will be stored in 16 blocks. Correct?
Okay.
Now, what would happen is these 16 blocks will be spread across these three. So let's say S1 will have 6 blocks, S2 will have 5 blocks, S3 will have 5 blocks. Okay. Now, instead of transferring the data from master to slave, what we will do is we need to write a counting of word program, like just count words. We'll send it to master. Then master will send it to S1, S2, and S3. Then S1 will run that program on these 6 blocks. S2 will run that program on 5 blocks. S3 will run that program on another 5 blocks. And will give the result back to master. Assuming, let's say this is 250, this is 200, this is 200, it will give you the answer of 650. Now here, if you are getting me, we are not transferring the data. Data is already there on the S1, S2, S3. So we are not using much of a network bandwidth. The network bandwidth that we need is just to transfer this 1 MB program. It is either 1 MB or less than that.
Okay, got it.
Make sense? Here, on the other hand, what you need to do is you will send 1 GB file here in master. It will split that file into 333 MB, 333 MB, 330 MB. Then send that 330 MB block each to S1, S2, and S3. And then program is already available here. So that program will run on that data and will return the result.
Yeah, okay, got it.
Yeah. This is actually very important concept because when we go into the Hadoop architecture program, it's going to get complex. A lot of terminologies are coming to picture, and you need to be very cognizant of this fact that data is not moving, program is moving. So yes, Akshay, do you want to ask something?
Yes, sure. And can the issue of the same bandwidth issue can also be like happen in the Hadoop distributed file system also, like in the first go?
I didn't get it. Can you come again?
Like in the in the traditional distributed file system, we are like transferring the data from master to S1, S2, and S3.
Yes.
And in the program, the distributed, we are just transferring the program. But before transferring the program, we assume that the data is already present in S1, S2, and S3.
Yes.
So while transferring the data, while transferring the data to S1 and S2, there can also be an issue of the same bandwidth what we were getting in the.
That issue can be there in traditional file system while you are loading data onto master.
Yes.
So we are not comparing that. That base condition is same. if you are assuming a case scenario that while there can be a network bandwidth issue while loading data onto S1, S2, S3, there can be a network bandwidth issue while loading a data on to master. That condition can be here also. So we are not taking that into consideration as of now. If you do that here, please do it here also, and then again Hadoop will win.